Hello, algebra students. Mr. Lawrence here, and we're going to be learning how to solve systems using, sorry, I had a little lag going on there, it was confusing me, using substitution. You know how to solve by graphing, and the real problem with solving by graphing when you have a system, of course I don't have a system up here yet, but if I had a graph and I had two lines forming my system, the first line was doing that, and then the second line was doing this. It would be very difficult for not using technology to tell what the solution to that system is. We know that it's intersecting there, but because if we're counting by ones or whatever, it'd be difficult to know because we're between two whole numbers. So we're going to be learning some other methods that won't fail us if the solution is not an integer, or the coordinates of the point are not an integer. Okay, but before we get to that, you've already been substituting. You already know how to do it. When we've had standard form equations and we try to find the intercepts, don't we find the x-intercept by letting y equal 0? And so we write 3x plus 4 times 0 equals 12. And so 3x plus 0 would equal 12, and then 3x would equal 12. And then divide by 3, and we would get x equals 4. Right? And of course we could find the y-intercept by letting x equal 0. Right? So we're going to substitute 0 in for x. So we're going to go 3 times 0 plus 4 times y equals 12. Now I'm getting pretty good at this. I know that's just going to turn to 0, so I'm just going to ignore it and get 4y equals 12, and then I'll divide by 4, and then y is going to equal 3. So the intercepts of this graph were found by using substitution. Well, we're going to do this with a system. It's going to seem a little more complicated, but it's really not that bad. So here we have a system of linear equations. We have 2x plus 3y equals 9, and x equals 3y. Now, one thing that is like pretty obvious, and it's almost so obvious it's hidden, is what x equals. You see, this equation here tells me that x is equal to 3y. That means they have the same value. Okay, so if x is 9, then y is 3, because 3 times 3 is 9. But the important thing is that x and 3y have the same value, just like 10 is the same as 2 times 5. Yeah, that's all it's saying. Now, if they have equal value, they can be substituted for each other. So I'm going to take this first equation, and in it, I'm going to substitute for x. Instead of putting x in the equation like it is here, I'm going to put 3y in parentheses in for x. I'm going to substitute it in. So I'm going to have 2, and then the 3y is going to go in here, like so. And then I'm going to have a plus 3y, and that's going to equal 9. Now, if you notice, I have one equation with one variable. I'm going to use my equation solving skills and figure out what y is equal to. All right, so first I'm going to multiply here and get 6y plus 3y. That's going to equal 9. Combining like terms is going to tell me that 9y equals 9. And I'll divide by the 9 and get y equals 1. All right, now notice I have an equation that says x equals. Remember, when I'm solving a system, I'm looking for the place the two lines intersect, the point. So I'm looking for an x-coordinate and a y-coordinate. Well, I just found a y-coordinate right there. Y is going to equal to 1. To find my x-coordinate, I'm going to take that highlighted equation. Go x equals 3 times 1. Yeah, I just substituted 1 in for y because y is the same as 1. So then x is going to equal 3. So what this means is, if we were to graph this, the two lines would intersect at the point 3, 1. That is the solution to the equation. And I'll tell you what I'll do here is I will make sure to graph this on Desmos so that you can see exactly what I'm talking about. Okay? And so what was it? The second equation was y equals 3x. And the first equation was 2x plus 3y equals 9. And let's see here. Well, something's wrong. I'm getting them intersecting at a different place here. Let me go back to the equation. Maybe I have a mistake. Oh, there's the problem. It's x equals 3y. And look at that. There we go. They're intersecting at 3, 1 just like they were supposed to. Now, this would have been an easy one to solve by graphing, but the problem is you often don't know what the solution is going to look like when you go to solve by graphing until you've actually graphed it. Excuse me. Substitution will show you the answer no matter what. Now, this was a pretty simplistic substitution problem because one of the variables was already isolated. Okay, so let's look at another example here. And in this example, oops, hold on a second. What I'm working on. In this example, I see that y is the same as x plus 2. Again, it's isolated. So in this problem, I'm going to take this x plus 2 and I'm going to substitute it in for y in the other equation. Whenever you substitute in, it always has to be in the other equation. If you don't substitute it into the other equation, you will end up with an infinitely true statement and not get the right solution. All right, so I've got 4 times the quantity of x plus 2 equals 8. And you can start to see how our equation solving skills come in really handy. I have to do the multiplication first, which is actually distribution. So I'm going to distribute the 4. And when I do that, I'm going to get 2x plus 4x plus 8 equals 8. Combining like terms is going to get me 6x plus 8 equals 8. And now it's just a two-step equation. I'll subtract 8 from both sides. I'll get 6x equals 0, dividing by 6. Will tell me that x equals 0. All right, now again, when I'm going to find that other coordinate, I want the equation that says that coordinate equals. It will always be there in substitution. You'll see in the next example how we have to work to get it there. It will always be there when we do this step. So I have y equals x plus 2, and I know that x is 0. So I'm going to have y equals, and I'm going to substitute in for x. And so I'm going to put a 0 there, and that means that y will equal 2. So these two lines would intersect at 0, 2. And I'm not going to go to Desmos on this one. I will let you verify that. All right, one more example, and that's going to be it for the video. Now, this one's a little more involved. It's not difficult, but it is a little more involved. So in this one, I don't have any variable that's alone. Well, some of my students over the years, they get like set in their ways. Well, I'm always going to solve for y, or I'm always going to solve for x. And I think that's a poor strategy. I'm going to look at which variable is going to be the easiest to solve for and give me the prettiest numbers. Like, for example, this isn't a great example of that, but if I had a system that looked like this, where I have x plus 4y equals 9 and 3x plus 2y equals 18. I don't know if you know which variable to solve for. But I'll bet you I am going to solve for this variable right here. Not because it's x, not because it's in the first equation, not because it's written down first, but because it's pretty easy to do. If I have x plus 4y equals 9, and I want to isolate the x, I'll subtract 4y away. This will get me x equals 9 minus 4y. Now I'm ready to substitute. If I had a system that looked like this, let's see, 8x plus 2y equals 12, and 3x plus 7y equals 1. Well, in this problem, this system, the variable I'm going to solve for is going to be this one. The reason being, I know that at some point when I solve for one of these variables, I'll have to divide. If I want to solve for this x, I'll have to divide by 8. The second x, I'll have to divide by 3. This y, I'll have to divide by 7, and this y, I'll have to divide by 2. Well, 8 doesn't go into 2 or 12 evenly. 3 doesn't go into 7 or 1 evenly. 7 doesn't go into 3 or 1 evenly. But 2 goes into 8 and 12 evenly. So if I were to have to solve this system, the first thing I would do would be to take that first equation and solve it for y. So I would subtract 8x from both sides. That would give me 2y equals 12 minus 8x. And then I would divide by 2. And so my equation would end up being y equals 6 minus 4x. And now I'd be ready to substitute. Now I'm not actually solving these because I'm pretty sure they're going to end up with really ugly answers. And this is just supposed to be a refresher video. So you can watch this ahead of time if you figure out it's there, or you can watch it afterwards to like reinforce what we did in class today. Or if you're absent, you can watch it. Okay, so I'm going to look at this one, and I'm going to try to decide which variable to solve for. And let's see, I could solve for this first x, which means I have to divide 10 by 20. Sorry, excuse me, and 21 by 20. Well, I don't like those prospects. If I go to solve for this y, I'll have to divide 20 by 10. I like that. 21 by 10. Dividing by 10 is not too difficult a thing to do. I think of the choices, I'm going to solve for this y. All right, so let me write down here 20x plus 10y equals 21. And I'm going to solve for y. Now, I have to divide by 10, but I have to do it all 3 places, right? Okay, so y is going to equal 2 1/10 minus 2x. Well, that's not so bad. Now to substitute, that was what I needed to do. That's like the prep work to substitute. I need to take this, and since it's equal to y, I need to go into the other equation and substitute it in parentheses for y. Just like this. I'm going to have 30x minus 10 and then I'm going to have the 2 1/10 minus 2x. So I'll solve this for x. First I'll distribute. And when I do that, the 30x is coming down. I'm going to have a minus 21 plus 20x equals negative 81. All right, I'm going to add 21 to both sides. And now I will know that 30x plus 20x equals negative 60. So this is going to be positive 50x equals negative 60. I'll divide by 50, divide by 50. I will simplify to negative 6/5. So x is going to equal negative 1 1/5. Now to figure out y, or by the way, that's the same as negative 1 2/10. To figure out y, I'm going to need to use this equation. You'll always have an equation in substitution at this point in the problem that says y equals or x equals depending on the variable you haven't solved for yet. It will be in that form every single time. So I'm going to take y equals 2 1/10 minus 2 times negative 1 2/10. And when I do that, I'm going to get 2 1/10 plus 2 4/10, which of course equals 3 5/10. So that means the solution to this system is negative 1 2/10, 3 5/10. And there you go. That's substitution. All right. That's Mr. Lawrence signing off. Have a good night, everybody.